Welcome back. This is 6.5 in the PDF book, which is 5.5 in your textbook, and this is on applying force. When you apply force, that's called pressure. So pressure is a force divided by an area, so a force spread out over a certain area. Imagine that you are standing on the floor. You've got the full weight of your body pressing down on the floor. That means the support force of the floor is pressing up on your foot, divided by 2 because you've got 2 feet, hopefully. So if you are standing on the floor and the support force is up, all of 1/2 of your weight is being pushed up onto your foot. If you step on a nail, 1/2 of your weight is pushed up on the point of that nail, and suddenly you've got a much more intense force over a smaller area. You've got a higher pressure. So that higher pressure may be enough to even puncture your foot. Hope not. So for the big idea here is for a constant force, an increase in the area of contact will result in a decrease of pressure. So as that nail, the point of that nail becomes, the whole floor, suddenly the pressure on your foot is less. So the math formula is really easy. You've got force, equals pressure times area, or pressure is force divided by the area over which that force is applied. So in air pressure, let's say you have all of the air column that's above you. The pressure of the air is pushing on every inch of your body, every square inch of your body. And in inches, I remember it's like 14.7, I think, pounds of air per square inch of your body. Because there's 100 miles of air until there's no more air. That 100 miles above you is shoving down on you, and that's called the air pressure. So if you have an air pressure of a Newton, so if the force here is a Newton, and then your area is a square meter, the pressure of 1 Newton per square meter is called a Pascal. And you're going to see pascals when we use air pressure. When we look at the gases, we'll use pascals as one of the possibilities of gas pressure. So if you have two books, and they're exactly the same weight, how you place them on the table will not change its weight at all, but does change the pressure. Which one of these books would have a higher pressure on the table? They've got the same mass, so that means they've got the same newtons of force, but the wider spread out book, sideways lying book, has a less pressure on the table than the book on its end because it has a smaller area over which that force is being applied. So this is what I was talking about before about standing on a nail. Since you're standing on a smaller area, you've got all the weight that you're pushing down on and the support force is pushing back on is reduced. And so if the area is reduced, since it's going to be pressure equals force divided by area. As the area goes down, the pressure is going to go up, and eventually you could pierce your skin. This is the author of the textbook, and I think he did this with I don't know whether it's his son or somebody, but please don't do this. Please do not die in an attempt to be funny. But I know that for centuries, especially in India, people would lie on bed of nails. I think some yoga practices or something like that. It's not that big of a deal because it would be almost like putting a hairbrush on the palm of your hand. All of the tines of the hairbrush are simply pushing equally, and essentially you've got so much area that whatever the force of the hairbrush is not going to puncture. Since you've got all of those nails, essentially it's closer and closer and closer to what the floor would be, and so it's not going to puncture you. Now, by breaking a cinder block, that might that might appear like all you're doing is pushing really, really hard onto those nails and it should poke you. But what he is playing with is Newton's first law. Newton's first law said that the heavier an object is, the more resistance to change of motion it is. So if he throws that hammer down into that cinder block has so much inertia that it doesn't want to move. It's lazy, it's sluggy in motion. So he breaks the cinder block without actually accelerating the cinder block very much. And since you have the nails spreading out the force over his stomach and his back, it doesn't hurt him either. It probably would dent him a little bit, but I don't think it would draw blood. But I'm not going to try this. I don't want to be sued. So in attempting to do the bed of nails demonstration, would it be wise to begin with a few nails and work upward to more nails? Great question. So is more nails scarier or is fewer nails scarier? The more nails there are, the less problem that you're going to have because it's more and more and more like the floor. The fewer nails that you have, the more pressure is going to exert because you have a smaller area over which that force is directed. So no, it would be there would be one less physics teacher if the demonstration performed with fewer nails. The resulting pressure would cause harm. Yeah, that would be me. So here's your last question. How does the area of contact affect the pressure a force exerts on an object? So what is your formula? Pressure equals force divided by area. So as the area increases, okay, so as this number goes up, what happens to the pressure? So remember, I can solve for P, I can solve for F here, P over A, and if they're on the same side of the equal sign, as A goes up, P has to come down. So if you increase the area over which a force is exerted, the pressure of that force reduces. As you reduce the area, the pressure increases. Hope that helps.